Hi and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe the features of metallic bonding. You should then be able to describe and explain the properties of pure metals and alloys. Metals are critically important in chemistry. I'm showing you here a gold bar, which is essentially pure gold, and also a guitar string, which is an alloy. And we'll be looking at what's meant by an alloy later in this video. So let's start by taking a closer look at metals. In the previous videos, we've seen that atoms become stable by gaining a full outer energy level. When a metal atom reacts with a non-metal atom, we see ionic bonding. However, when two non-metal atoms react, we've got covalent bonding. So let's take a look at bonding in metals. Metals consist of a giant structure of atoms arranged in regular layers, and I'm showing you that here. In a metal, the electrons in the outer energy level of each atom are delocalized. So let's take a look at what that means. Here I'm showing you atoms of the metal lithium. Lithium atoms have got 3 protons in their nucleus and 3 electrons in their energy levels. Now the key fact is that in metals, the outer electrons are not attached to any individual atom, so they're free to move. Scientists call these delocalized electrons, and I'm showing you these here. Scientists call this a sea of delocalized electrons, and it's often shown like this. Now, because each metal atom has lost its outer electrons, we now refer to them as metal ions. But remember that this is not ionic bonding, this is metallic bonding. So the key fact is that we have a strong electrostatic attraction between the sea of delocalized negative electrons and the positive metal ions. Remember that an electrostatic attraction is an attraction between a positive object and a negative object. Scientists call the electrostatic attractions in metals a metallic bond, and metallic bonds are strong. Now, the strong metallic bonds explains one of the properties of metals, and that is that metals have got high melting and boiling points. That's because a great deal of energy is required to break the strong metallic bonds. The delocalized electrons also explain another property of metals. Metals are excellent conductors of heat and electricity. That's because the delocalized electrons can move. Because electrons are charged, these moving electrons can carry an electric current. Also, the moving electrons can carry thermal energy, which allows metals to conduct heat. Let's look at another property of metals. Metals can be bent and shaped. That's because in metals, the layers of atoms are able to slide over each other like this. You really need to learn this as it's a key property of metals. So just to recap, metals can be bent and shaped, and that's because the layers of atoms can slide over each other. Now, this does give us a problem. Some pure metals just aren't hard enough to be useful. This includes copper, gold, iron, and aluminium. So we need to make these metals harder, and to do that, we make an alloy. An alloy is a mixture of metals. The different sizes of atoms distorts the layers, making it more difficult for them to slide over each other. This means that alloys are harder than pure metals. You'll find plenty of questions on metals and alloys in my revision workbook, which you can get by clicking on the link above. Okay, so hopefully now you should be able to describe the features of metallic bonding. You should then be able to describe and explain the properties of pure metals and of alloys.